El pasado 4 de abril tuvo lugar el encuentro científico con Anne Louier. La científica, que además es miembro de la Real Academia de las Ciencias de Suecia, obtuvo el Premio Nobel en 2023 por el desarrollo de nuevos métodos de ionización con láser, para obtener pulsos de luz ultracortos del orden de attosegundos, y que permitirá estudiar el comportamiento dinámico de los electrones dentro de los átomos, las moléculas y la materia. Elena Ramírez, estudiante del IE San Fulgencio, junto a su profesor de Física y Química, Mario, pudieron preguntar algunos aspectos interesantes de su investigación, así como sus logros y dificultades en esta área de las ciencias. Es un honor para nuestra comunidad educativa del IES San Fulgencio compartir esta experiencia con Anne. A continuación os dejamos con la entrevista al completo.
Yes, let's go. So thank you so much, Anna, for your taking your time. It's a pleasure for us to be here in front of a Nobel Prize like you, Anna Louier. Thank you so much, really. First of all, we are going to start with the presentation. I am Mario, the teacher of Physics and Chemistry of Elena. And on my right, this is Jesus, you can see. This is the master of the center, the box. Before starting the conversation, we want to say or dedicate some words to you.
Okay. Hello, Anne. Thank you very much. Here we are all excited for this meeting that you have offered us to Elena and Mario. As our representatives to this high school, Andalusia High School in San Fulgencio, I want to thank you deeply for this meeting to talk about science with Elena and Mario. Merci beaucoup. Nous espérons pouvoir vous rencontrer une prochaine fois, mais en tête-à-tête.
Thank you, Box. And for there, this is Vice Principal, our language teacher. She's Carmen Elena.
Nice to meet you.
And then finally, this is the special and incomparable student of science, Elena. This is the moment. She has been waiting this moment, very, very exciting. Where you go?
Hi Anna, I am Elena. I am a passionate student of science and I follow your research. Also, I want to send this special opportunity to share with us and the possibility of asking some questions. But before that, I want to show you this.
Yes, I saw that in the mail, yes.
This is a portrait of you that I painted in orden to carry on my project.
Okay,
This is a present for you and I hope you like it.
thank you.
You're welcome. In this project, I read about your research on laser, ultracortos, and astrophysics, and it was very interesting. It is a little difficult for me, but I try to understand it. So my first question for you is this. What advice would you give to those aspiring to start a career in physics?
It's a very difficult question. I think you should choose the topic that you like very much.
Okay.
That's my advice. And you should, yes, and then you should be prepared to, of course, work quite a lot. But you should again, this is something you should like, and then you should be very focused on that. Yeah.
She's very passionate in science.
Yeah, passionate. Yeah.
Okay, thank you. And the second question I would like to ask you is this. What events do you see we will see in a future in the field of physics?
This is also very difficult, and I don't, it's not that I know everything in physics by far. There are many interesting topics. For me, astronomy and cosmology are really exciting at the moment because there are so many questions. But the field of my own research is still very exciting. There is a lot of new things to understand and to improve. So there is a lot to do. So I see many things in physics that are very interesting. So you should decide by yourself what you like best.
Okay, so
if you like to do experiment, if you like to do theory, if you like to work with big collaboration, big instruments or smaller things, it's up to you. If you want to do more applied or fundamental, this is up to you.
okay.
So, any questions for Anna?
If Professor Anna let me the last question, I would like to ask the last one.
Say one more time.
My teacher taught me an experiment with a laser, leads, and a double slit. In this experiment, we see how the material have different behaviors, particles and weights.
Yeah.
We could see different patterns of light and even measure the size of a human hair. It was very interesting. So could you send us or tell me another experiment that we can do in the lab with a green laser and also an oscilloscope, please?
Anna, in the lab, we have the equipment simple but like similar oscilloscope. And I think that in relation to your experiment or similar, if you can say us some experiment in relation to that.
This is really difficult. I mean, if you have a laser like you show, I think you can do fun experiments by with slits. I would do like that. You have two slits and you look at the interference pattern and you try to play a little bit with that. Then you can use a prism and look at the different colors. This is also very interesting. You can do that. You can look at the sun. I don't know if you can. Yeah. No, I don't know. No. Yeah.
I search in the web.
Yeah.
So any more or Anna, if you consider, I have a short question.
Yeah.
I read several papers related to your Nobel Prize. You say when you irradiate or excite the atom of xenon gas, the electron go upward to the level, and when the electron come back into the nucleus, emit a specific light, ultraviolet light concretely. So, and then you obtain an overtone that you produce an ultra short pulse of frequencies of attosecond, 0.18. So why do you use this specific atom, xenon gas, argon? Why don't you use another type of atom, for example, molybdenum, copper, silver? Because this atom is used to produce X-ray diffraction. It's related to the different level of the electronic configuration of electronic of atom gas, xenon, argon. What happened exactly?
It's because these rare gases are they have a full shell, so they are actually very difficult to ionize. the ionization energy is very high.
In the attosegundos or noble
like
gas.
Argon or yes.
And in this way, you produce the ultra-short pulse.
These atoms can be exposed to a high laser intensity. If you have a simpler atom like I don't know, copper or something like that, I don't know. If you send a laser, then the atom will be ionized.
It's more easy.
It's very easy.
Okay.
So that if you have a laser pulse, the atom will be ionized at the beginning of the pulse. The intensity will not be very high.
Okay.
So if you have a rare gas like argon, at the beginning nothing will happen. It's very difficult to ionize the atom, so that these atoms can really feel a very high intensity, a strong laser.
Okay.
And in that case, you can have this emission of harmonics and also this emission of very short light pulse, because in that case the electron will be emitted by not by photoionization but by tunnel, and then the electron come back and produce these very short light pulses.
Effect.
Yeah.
Okay.
And this is and very short. But this is because you have a strong laser atom interaction, and only these atoms which are very bound can be exposed to such high intensity. I don't know if this is clear, but yeah.
Okay, I think that your method seems very simple and very nice. It's a Nobel Prize, of course.
Yeah.
But
yeah.
I think that is very complicated.
Okay, yeah.
So,
Please, another question.
Yeah.
My teacher showed me an experiment. In this experiment, you can see the moving of atoms in a reaction. I see this experiment is called ionization of Vermont.
she's referring a very well-known reaction where you can observe in the same molecule, you can observe how bonds are formed or are broken during reaction. I think it's related to your experiment.
In that
I think the little bit challenge or aim of attosegundos physics is to do that, to follow the beginning of the reaction. Yeah, that would be very, very interesting.
And in that experiment, they have a photography of the atoms. But in your experiment, what kind of signal could you observe? Really, could you observe the moving of the atoms or electron? Or you can observe other type of signal?
I think what we would like to do is not only see the movement of the atom, but really movement of the electrons. That's the idea. That's the aim. But it's very difficult. We do that in atoms, but it's only beginning with molecules.
You have to interpret the signal.
Yes,
okay.
This is very difficult, yes.
Okay, so...
Okay. So Anna, that's all of our part.
Okay, thank you very much.
It's time to say goodbye, but I have to say you that it was an honor for me have said this moment with you, and probably in the future I study something related with the astrophysics because it's very interesting.
Well, I wish you good luck with your studies.
Anna, thank you so much for your time. And congratulations on your Nobel Prize Physics, on Nobel Prize Physics, and thank you so much for your consideration.
Thank you very much. Where are you?
In Spain, from Spain.
Where?
The sur of Spain, Seville. Do you know Seville?
Sevilla, yeah.
Have you been?
Okay, I know.
Ah,
yes.
Okay.
Okay, thank you very much.
Okay, thank you so much. Bye bye, Anna.